Do you remember how many types of
So
decimal
3.
numbers we discussed in the previous class?
3.
So
3. Tell me, what are the 3? What
sir,
are the
I think
3?
2, sir.
Yes.
Terminating decimal and the non-terminating decimal.
See this screen, my dear children. In the previous class, we have discussed these two types of decimal numbers. First one is terminating decimals, and the second one is non-terminating recurring decimals. These are also called non-terminating repeating decimals. For example, 0.1 bar. What is recurring here? Can you tell me? In this decimal number, what is recurring? Yes, very good. 5.3 bar. How do you read this number? Can you read this number, my dear Krish? How do you read this number? Anmolji, 5.3. How do you read this number? Anyone? Please raise your hand. Yes, very good.
So
Srujana.
5.3 bar.
Very good. Very good. Srujana. This number, how do you read this number? Who will read this number?
Sir, 0.27 bar.
Yes, 0.27 whole bar. You should read it as whole bar because all the digits were written under bar symbol. Who started recording? Anyone started recording? Anybody started recording, my dear children?
No, sir.
Okay. Here it is a starting recording. Okay. How do you read this number?
So 3.176 bar.
Yes. 3.176 bar. Here bar symbol is given only for the digit 6. Okay, my children. These are the two types of decimal numbers we had discussed in the previous class. Terminating decimal means in the long division we get the remainder as 0, whereas in this case non-terminating repeating decimals, we have discussed these examples. We have divided 13 by 7. If we divide 13 by 7, here a block of digits, here we have written remainder is 6, here remainder is 4, here remainder is 5, here remainder is 1, here remainder is 3, here remainder is 2, here remainder is 6. We got the same remainder as we got here remainder 6. Here we got remainder 6. Here also we got remainder 6. So we stop this division by this step and we write bar symbol from here where that 6 started, here 7 8. So from 8 we had to keep bar symbol for all these digits, 7 8s. Below 60 7 8s. Yes or no? So from this number 8 we had to keep all these digits under bar symbol. Got this point, my dear children?
Yes, sir.
Yes. Especially these are called pure recurring decimal. After decimal point, every digit after decimal point were written under bar symbol. This is also called pure recurring decimal. This is also called pure recurring decimal. But in this case, this is a mixed recurring decimal because after decimal point, if you observe this number, if you observe this decimal number, after decimal point, two digits are not repeating, whereas 6 is repeating infinitely many times. Understood the difference between these three numbers and this number, my dear children? In these three numbers, all the digits after decimal point, every digit is repeating infinitely many times. Here this block of digits 27, 27, 27 like this. This block of digits repeats infinitely many times. Whereas in this example 3.176 bar, in this case here 6 only repeating, only 6 is repeating. Got this point, my dear children? So just let us write the examples for pure recurring decimals and mixed recurring decimals. Are you watching the videos, my dear children, regularly? I am posting the videos of the classes. Are you watching the videos? Krish, Shanti,
Yes, sir.
Yes, sir.
Darikar, yes. Please watch the videos regularly. I am posting the classes. Every day I'm recording the classes and I'm posting them as a YouTube link. Okay, my dear children. The Rikar Lingua, you are not attending regularly for mathematics classes. What happened, my dear Darikar Lingua?
Sir, because I was in my aunt's funeral.
What? Sorry?
Sir, I was in my aunt's funeral.
Okay. Please attend the classes regularly. Okay. In case if you missed the classes, please watch the videos which I posted in the Google Classroom. If anyone missed the classes, then watch the videos in the Google Classroom which I am posting them in the Google Classroom. Okay, my dear children. Right. My dear Sakshi, you also not attending regularly. Sakshi, are there Sakshi? Okay, now come to this point, pure recurring decimals. Pure recurring decimals means, for example, 2.3 whole bar, 0.73 whole bar, 10.7 bar, 237.421 whole bar are examples. Now can you tell me, Nikita, my dear Nikita, are you there online? Are you there online, Nikita? Nikita? Rahul?
Yes, sir.
Yes. How will you read this one?
2.3 bar, sir.
Yes, 2.3 bar. Are you able to watch the screen?
Yes, sir.
Yes. In this number, what is repeating here? What is repeating here? 2.3 bar. In this number, what is repeating here?
421.
2.3 bar. In this number, what? Tell me, Sridarshan. Yes,
Sir,
3 is
3.
repeating. 3 is repeating. In this number, 0.73 whole bar, what is repeating here?
7, 7 and 3.
Yes,
7
7
and
and
3.
3. So in this case, we say that the block of digits 7, 3, the block of digits 7, 3, or a group of digits 7, 3 is repeating infinitely many times. In this number, what is repeating?
Sir, 7.
Yes. Here, in this number, what
Sir,
is
4 to
repeating?
1.
4 to 1. Yes. In all these numbers, if you observe, after decimal point, whatever the digits are there, every digit, the block of digits is repeating infinitely many times. That is why these are called pure recurring decimals. And second kind of pure recurring decimals is mixed recurring decimals. Mixed recurring decimals. Mixed recurring decimals. In these numbers, two point 2.37 bar, 2.37 bar, 14.265 bar, 0.258 bar, 0.34567. 67 is a bar. If you observe these decimal numbers, after decimal point, some digits are not repeating and some digits are repeating. How do you say which digits are repeating? On what basis can you identify the digits are repeating? Yes, my dear Sridarshan, tell
Sir,
me.
by using bars.
Yes, bar symbol. By observing the bar symbol, we can identify which digit or which group of digits is repeating. Here, what is the repeating part here?
7.
Only 7 is repeating. In this number, what is repeating?
Sir, 5.
In this example, what is repeating? 58. The block of
Sir,
digits.
5, 8.
Yes, 58, 58, 58 like this, and so on infinitely many times it repeats. In this example,
Sir, 6, 7.
Sir, 6, 7.
Yes, 6, 7. So, by observing these examples, you understand which digit is repeating or which block of digits is repeating. Got this point, my dear children?
Yes, sir.
Yes, sir.
Yes. Yeah. Next point. Sometimes, okay, period and periodicity. Actually, these concepts were not given in our NCERT textbook. Period. In a recurring decimals, the digit or block of digits which are repeating is called period. In a recurring decimal, the digit or block of digits which are repeating period of the decimal number. In this example, can you tell me what is the period of the decimal number? In this example, understood this point, my dear children? The digit or block of digits, the digit or which block of digits which is repeating infinitely many times, that part is called period of the decimal number. Now, can you tell me in this number what is the period?
Sir, 3.
Sir, 3.
Yes, very good. In this number, what is the period?
Sir, 7, 3.
7, 3.
Yes. In this number,
7,
Sir,
sir.
7.
in this number,
Sir, 4, 2,
4,
1.
2, 1.
in this number,
Sir, 3,
7.
7.
7.
in this number,
Sir, 5.
in this number,
5, 8.
in this number.
6, 7.
Yes, very good. This is about period of a recurring decimal number. Next point, periodicity. Periodicity is nothing but the number of digits which are repeating in a recurring decimal number. The number of digits
Sir, can you show the previous page?
What, my dear Rahul?
Sir, can you show the previous page?
Screen. Are you not able to see the screen?
Sir, can you show the previous page?
Previous one.
Okay.
I will repeat. Don't worry. I will explain these 2 points with examples at a time. Okay, my children, don't worry. So, non-terminating See, the number of digits which are repeating infinity many times in a non-repeating, non-terminating recurring decimal number is called periodicity. Can you tell me in this example what is the periodicity? What is periodicity? One. Only one
So,
digit is repeating. What, my dear Bibina?
sir, I said 1, sir.
Ah, yes, very good. In this number, what is the periodicity?
So 2.
Very good.
2.
In this number, what is the periodicity?
Sir, 1.
1.
Sir, 1, sir.
In this number, what is the periodicity?
Sir, 3.
Yes.
Sir, 3.
4 to 1.
In this number,
Sir, 1.
Sir, 1.
only 1. Periodicity is 1 only. In this number,
Sir, 1.
1. In this number,
Sir, 2.
in this number,
Sir, 2.
yes. I'll prepare a table for these 2 points. Okay. Decimal number.
Sir, can you please move the note little bit, sir?
Ah, yes, yes. Okay, now is it okay?
Yes, sir. Now okay, sir.
See these examples, my children. I have taken some non-terminating recurring decimal numbers. Now we have to write period and periodicity. For this number, what is the period?
3. Sir, 3.
Periodicity?
1. Sir, 1.
Yes, 1. In this number, what is the period?
7 3.
7.
7, 3.
What is the periodicity?
2.
2.
2.
What is the period?
7.
So 7.
What is the periodicity?
1.
So 1.
1. This knowledge is very useful after we use
Sir,
this knowledge.
period is 4 to 1.
For this number, period is 4.
4 to 1.
Periodicity?
3.
So 3.
What is the period?
So 7.
Periodicity?
1.
1.
So 1.
What is the period for this
5.
number?
So 5.
Periodicity?
1.
1.
1. What is the period?
8.
Sir, 5, 8.
2.
So 2, sir.
Understood this point, my dear children? What is period
Yes,
and
sir.
what is periodicity and what is pure recurring decimal number? What is said to be pure recurring decimal number and what is said to be mixed recurring decimal number?
Yes, sir.
Yes.
Yes, sir. Yes, sir.
Yes. Very good.
Can you show the page?
Yes. What, my dear
Sir, can
Krish?
you show the table?
Do you want to explain again?
Yes, sir.
See, right from the beginning, I'm telling you. In the previous class, we have discussed that there are 2 types of decimal numbers. We will discuss one more decimal number. Is there one more kind of decimal number? We discuss it later. For this case, in this context, just we are discussing these two types of decimal numbers, namely terminating decimal number and non-terminating recurring decimal numbers. Okay, we get terminating decimal numbers when we are doing long division. In the long division, when we are getting remainder 0 like this, here we got remainder 0. In the long division, we got remainder 0. In this case, we get terminating. Terminating means ending. That long division comes to an end. It means we are getting remainder 0. Understood this point, my dear children? Understood, my dear Krish?
Yes,
Yes,
sir.
sir.
Krish? Not responding. Krish? In the long division, when you are dividing a number by another number, if you get remainder 0, then we get a decimal number. Then the decimal number is called terminating decimal number. Got this point, my dear Krish? My dear Krish?
Very good.
Now come to the non-terminating recurring decimal number. When you divide a number by another number, if you divide a number by another number, we don't get a remainder 0. That long division continues. That process continuously, infinitely, many steps, takes many steps, infinitely, many times. Many steps will take. We never get remainder as 0. We don't get 0 as a remainder. Understood this point, my dear Krish? In the long division, we never get remainder 0. In that case, we get a decimal number. That decimal number is called non-terminating. Non-terminating means that long division does not end. It means we are not getting remainder 0 in that long division. Understood this point, my dear Krish? Krish. So, in this example, if you divide number 10 by 3, we are getting the remainder 1. Again, remainder 1. If we get the same remainder, we stop the division. We stop the division by that step. And we keep here bar symbol. Where we stopped that division, then we give the bar symbol 0.333 and so on. So 0.3 bar. This is read as 0.3 bar. I wrote it clearly in the previous class. Okay, my dear Krish. Now, in this class, I explained class.
Sir, carry table.
What, my dear Krish?
Sir, carry to the table.
So, do you want to see this example? Another example?
No, sir, I want to see the table.
You are not clear? Ask your doubt clearly.
Sir, I want to see the table, sir, which you don't know.
Is that point clear? Krish?
No, sir.
So in this second example, we have divided 13. We have divided 13 by 7. We found here remainder 6. Here we got remainder 4. Here we got remainder 5. Here we got remainder 1. Like this. If you observe the reminders, when you get the remainder, same remainder, whereas we got previously some reminders, if we get any remainder repeated, we stop that long division. Here remainder 6, here also we got remainder 6. So we stop this long division by this step, because again the same remainders will continue. We get the same remainders again and again and again, infinitely many times. We never get 0 as remainder. What, my dear Krish?
Sir, Sir, it's more, no?
Huh?
Yes,
What, my dear Krish? Otherwise, write message, send a message, write your doubt, ask your doubt by writing your message, send your message. My dear Krish. So, we got remainder 6. We stopped that long division. Then we got here a decimal number. This is called non-terminating recurring decimal number. That is why we classified the decimal numbers in this context. One more kind of decimal number is there. We discuss it later. In this context, we define here two types of decimal numbers: terminating decimal numbers and non-terminating recurring decimal numbers. Again, for our convenient, we again classified the recurring, non-terminating, repeating decimal numbers as pure recurring decimal numbers and mixed recurring decimal numbers. Only for our convenient to understand the decimal numbers clearly, I explained these 2 points. Actually, these 2 points were not given in our NCERT textbook. What is meant by pure recurring decimal numbers and what is meant by mixed recurring decimal numbers. Okay, my dear children. Yes. And moreover, after finding pure recurring decimal numbers and mixed recurring decimal numbers, we discussed period and periodicity. We define these two terms with respect to recurring decimals only, not with terminating decimal numbers. We discuss these two terms with non-terminating recurring decimal numbers only. In the non-terminating recurring decimal numbers, the digit or block of digits which are repeating infinitely many times is called period of the decimal number. If you observe these examples, we wrote period, here 3 is repeating, here 7 3, this block of digits, this group of digits, 7 3 is repeating infinitely many times. In this example, 7 is repeating infinitely many times. In this example, 3 digits, the block of 3 digits, 4 2 1 is repeating infinitely many times. In this example, only 1 digit, 7 is repeating. In this example, 5 is repeating. Just by observing the bar symbol in the non-terminating repeating decimal number, we can identify period and periodicity. Understood these 2 points, my dear children? For a non-terminating recurring decimal numbers, what is period
Yes, sir.
and what
Yes.
is the periodicity? We use this concept, we use this knowledge in writing the non-terminating recurring decimal numbers in the form of P by Q. We use this knowledge when we are writing a non-terminating recurring decimal numbers in the form of P by Q. Okay, my children. Now, in the previous class, we had discussed how to write a rational number in the form of decimal number by using the long division. Do these homeworks sums in page number 14. All of you got the textbook opened, my dear children?
Sir, 1 minute, sir.
All of you open the textbook, page number 14. Page number 14. Open the textbook, my dear children. All of you open the textbook, page number 14. Exercise 1.3 is there. Exercise 1.3.
Yes, sir.
In that exercise 1.3, what is the first question? Can you read, my dear? Harini, you are also not attending the classes. Harini, you are also not attending the classes regularly. Why are you not attending the classes? Harini,
Yes, sir.
why are you not attending the classes?
Sir, I'm attending regularly.
You are
I'm attending, sir.
not attended. Harini, okay. You are absent for 9th and 10th. 9th and 10th of this month. Yes or no? 2 days absent. Last week, 2 days absent. Okay, have you opened the textbook, my dear Harini?
Sir, I don't have, sir.
Please download the NCERT textbook from the NCERT website.
Okay, sir.
All of you, my dear children, download NCERT textbook. Okay, my dear Sridarshan. Don't worry, my dear Sridarshan.
Okay, sir.
In 14 page number 14, can you read, Bibina? Please read the question number 1.
Okay, sir. Okay, sir. Write the following in decimal form and say what kind of decimal expression each has.
How many types of decimal numbers we have discussed? How many types of decimal
Sir,
expansion?
2.
Only 2 types. In this context, we have discussed only 2 types of decimal expansions. They are also called decimal expansions. Just for your convenience, I told them decimal numbers. For your convenience to understand that, to remember that terms well, just I told you terminating decimal number, non-terminating decimal number, like this. Okay. Now, here some rational numbers are given. Some rational numbers are given. We have to write them in the decimal expansion. In the decimal expansion means in the decimal number by using long division. Okay, my dear children. By using long division, we have to write the rational number. We have to write the rational number in the decimal form. Okay, my dear children. See that page number 14. Can you tell me the first question? What is the first question?
Sir, 36. Sir, 36 by 100.
36 by 100. Then, how do you write this number in the decimal expansion? How do you write this number in the decimal form? How do you write this number as a decimal number? 36 by 100. Anyone? Can you tell? Here denominator is 100. When the denominator is 100, it is easy to write the given rational number as a decimal number.
0.36.
Very good. Yes, 0.36. Very good, my dear Srujana.
Sir, can you move the screen, sir?
What,
Little
my dear
bit.
Bibina?
Sir, yes. Sir, okay, sir.
Okay. If the denominator is 100 or 1000 or 10 multiples. Okay, my dear children, not 10 multiples, 10 square, 10 cube. Don't confuse, not 10 multiples. 10, 100, 1000, 10,000, like this. If the denominator is there, then we can write that rational number easily in the form of decimal number, like this. How many digits are, how many zeros are there in the denominator after 1, 2.
Sir,
Yes or no?
2.
So we write the numerator as it is. Right, we count the digits from right side. From right side, we count the digits. How many digits after we keep the decimal point? Based on the number of
2,
zeros.
sir.
Based on the number of zeros after 1 in the denominator. Here 2 zeros are there. So after 2 decimal numbers, after 2 numbers, very good. Okay, my children. Now come to the next question. 1 by 11. 1 by 11. How do you write this number in the decimal expansion? How can you write this number in the decimal expansion? Here denominator is not 100, not 10, not 100, not 1000, not 10,000.
Sir, we must divide.
Yes, very good. We must divide numerator by the denominator. So here I am doing that part. I am dividing 1 by 11. Can you divide 1 by 11? Yes, by long division only. With the help of long division only, we can write this rational number in the form of decimal expansion. Yes, we have to keep decimal point, 0 point. Not only point, you should tell 0 point. Then what will you get here? 10 only. After keeping a decimal point, we are able to write 10. Not more than 10. Only we are eligible to write 10. If you want to write one more 0, here we can't divide 10 by 11. Yes or no? We can't divide 10 because smaller number. This is smaller number. This is a bigger number. So we want one more 0. In that case, we have to keep another 0 here and we keep here 10. Understood these steps, my dear children? My dear Krish, Harini, Shanti,
Yes, sir.
Kavya.
Yes, sir.
First we kept decimal 0 point. Decimal number we kept 10. Then we got only 10. We can't divide 10 by 11 because 10 is a smaller number, 11 is a bigger number. So we want one more 0. To get one more 0, again we keep here 0 and after 10 we keep 0 here. Now we can divide because this is 100 is a bigger number, this is a smaller number. How many times? Can you tell me how many times this goes? How many times?
Sir, it goes by 9 times.
So when you are doing long division, please write the table. In the rough work, write the table. 11 2s 22.
Sir, 11 nines are 99, sir.
Okay, this is the easiest table. That is why you can tell the answer easily. But in case of some other numbers, you must prepare table like this. Okay, my children. 11 4s 44. 11 5s 55. 11 6 66. 11 7s 77. 11 8 88. Like this, you must prepare table. You must prepare table. Okay. 11 9s 99. 11 10s 110. So 11 nines. Then what will you get here? What will you get here?
Sir, 1.
1. Again, we are able to keep 10 because we have already kept decimal point. Okay, my children. Again, if you want to write one more 0, we have to keep 0 here. And we keep here 0. Here remainder is 1. Okay, remainder. Remainder is 1. Again, how many times it goes? Tell me.
Sir, non-terminating decimal.
Yes, non-terminating, repeating decimal number. Tell me here. 11 nines, yes or no? 11 nines. Then what will you get here? Remainder?
1.
1.
Remainder 1. We got the same remainder here. Previously I told you when we get the same remainder, we stop this long division. and we keep bar symbol. Okay. So again we get 090909 like this. So 0.090909 and so on. This can be written as 0.09 whole bar. Understood this point, my dear children?
Yes, sir.
Yes. Will you do the remaining sums as homework in this Roman?
Okay, sir.
Yes. Do the remaining
Yes,
sums
sir.
as homework. Now the time is, yes, this is a non-terminating repeating decimal number. Okay. This is a non-terminating recurring decimal number. Decimal expansion. You can write. This is terminating. Yes or no? Terminating decimal expansion. Okay, my children. Now the time is 11 past 50 minutes. Sorry, 9 past 50 minutes. Now you can leave the meeting, my dear children. Take rest. Take care of your health, my dear children. Stay at home. Stay safe. Use mask. Use sanitizer. Maintain social distance.
Thank you, sir.
And write the classwork notes. And submit your classwork notes regularly. Don't be lazy in submitting your classwork notes. And watch the videos also, my dear children. If anybody is missing or if anyone joined the meeting late, watch the video completely and then write the classwork notes also. Okay, my dear children. Do the homework sums. When you are writing the classwork notes,
Thank you, sir.
Previously I told you write the question as well as answer. Not only simply answers. Don't copy the answers from my PDF. Okay, my dear children. Thank you, my dear children.
Thank you, sir.
Thank you, sir.
Thank you all.
Thank you, sir.
Thank you, my dear Darikar.
Thank you,
Thank
sir.
you.
Thank you, Janesh and Moldeep. Nikita, Sakshi, Bibina, still you are online. Leave the meeting. You can leave the meeting, my dear. Nikita and Sakshi. Nikita and Sakshi. My dear Nikita and Sakshi, still you are online. Please leave the meeting and get ready for the next class. Get ready for the next class, my dear Nikita. Are you there online or not? Sakshi, please leave the meeting and get ready for the next class. Nikita, still you are online? Nikita, still you are online? Please leave the class, my dear Nikita, and get ready for the next class. Nikita, ma Nikita, still you are online? My dear Nikita, where stay online? Leave the meeting, Nikita.